Hi, I'm Tim Berglund with Confluent.
And I'm Victor Gamov with Confluent.
Today, we're going to talk to you about how to make streaming pipelines using Kafka, Flink, and Pinot. These are three technologies that really go well together.
Yes, and this will include 2 live demonstrations, so stick around if you're interested to see how it works in a real life.
It'll be 3 if Victor gets carried away.
Exactly.
Anyway.
Tim, let me ask you a quick question. So we both spent some time with Apache Pinot, but I believe you spend more time and you develop a lot of educational materials for Apache Pinot. Can you walk us through about what's your elevator pitch about Apache Pinot?
I would love to. So fundamentally, it's a real-time distributed OLAP database designed to serve analytics workloads, but it focuses on streaming data and queries served at very low latency with high concurrency. That's a mouthful, so let me break those things down one at a time. Now, the very essence of real-time analytics is latency. That's at the top, okay? This is the amount of time it takes to execute a query, and they need to be very fast. Also, though, we need many concurrent queries because these are often things that are facing a user interface. And so instead of a couple dozen people looking at a dashboard, you might have hundreds of thousands, millions of people using an app. And as a result of the real-time world and the world of streaming, we need data to be very, very fresh. There are events happening. They're coming through Kafka pipelines, being processed by Flink, and we need them to be available to be queried right away. Now, fast and a lot and all that, these are all relative terms. So what do we mean by that? Let's put a little meat on the bone. Latency can be, in Pinot, as low as 10 milliseconds. That's on real production data, actual queries. 100,000 queries per second in a Pinot cluster. That's a thing people do. And the latency is the latency of your data pipeline. Once an event is consumed from a Kafka topic into Apache Pinot, it's available for the next query right away. There's no additional latency imposed or freshness delay imposed by Pinot.
Speaking of which, we have very important slide before we jump into the demo, but the Pinot is focused on telling the story. When we're talking about transactions, we care about one particular message. In this case, we might be credit card transactions. But when we're talking about all app system, we focus about the story. And what kind of story we're trying to tell with the information about credit card transaction, we can tell a story about what's the consumer satisfaction rating, or like what kind of group of goods people are buying. So that's kind of things that Pinot is very good at it. So there's good databases to deal with the OLTP. Pinot is good on all app analytics.
Yes, where queries focus on or queries retrieve lots of records, not just one. And it uses tables. There's nothing to see here. They're all very familiar, very simple. And instead of DDL in SQL, you actually express that in JSON because it's very complex. There's a lot of things you have to define potentially to create a Pinot table. So rather than all that custom SQL, it's just JSON. And the queries, though, are expressed in regular old SQL. And you'll see that when Victor does the demo.
And this is very important because for the context of data engineers or streaming data engineers, SQL is still the dominant language for describing both projections on your data when you're performing any type of queries, or even things that you will see later today is to perform some of the distributed computation using SQL as the dialect to implement those jobs. We go into the world of streaming ingestion. Pinot has very good integration with Kafka. There is a very intimate connection between Pinot and Kafka, but also there's a very good connection between my Confluent Cloud cluster, where I have all the data. As you can see, a topic with some flights. Flight information will be arriving with some of the regularities. So there's airlines are running. So it's a live stream, things are coming in. Also, we include the schema in our data. So not only our internal systems would know how to consume the data in what format, but also external systems like Apache Pinot in Star Trek Cloud would know schema of my data, so that will infer a table structure inside the Pinot. So with this information from the schema registry, the Star Trek Cloud data manager was able to infer schema about our flight formation. And if I would perform something here, it will showing some data, but if I will do select star count, So we can see that data will be arriving as it was generated on the Kafka side. So if I run this, it has, that's the number we have right now, 186,000. But if I run this again, this number is changing, as you can see. So let me do this bigger. And this is why the messages that were published in the Kafka topic are available immediately inside the Pinot for consumption. So that's the part where you just point your Pinot cluster to Kafka topic, and this topic will appear inside your Pinot table. And you will be able to do all things what you like to do with Pinot. You just create indexes, start writing very high-performant queries, and so far and so on.
And as Victor said, that's a very intimate integration. You don't use Kafka Connect as you typically would with a database or data lake or something like that. Pinot is a Kafka consumer by itself, and it does some special things. That's fun stuff to look into on your own in another talk or to research how that works. It really is kind of a value add between the two, that they grew up together.
I heard there's a very good training course that's available on the StarTree website that talks about some of the streaming aspects and in batching aspects of Pinot in integration with other systems. So check it out. Which brings us to the topic of today's conversation: how we're gonna build some of the cool pipelines. Because we're getting data from Kafka topic in the Pinot, it's easy, but in real life, in the more complex use cases, life is not that perfect. No one builds the schemas, for example, for you, or maybe you're getting data not in a well-structured format. But before that, so Tim will help me to introduce you to Apache Flink. So Apache Flink is the thing that we are working very closely these days, and there's a little bit of a little bit for everyone. I'm a Java developer. I love tinkering with code. Flink provides me a very rich API. For people who don't like to do this, there's another ways.
There's SQL, yeah. But fundamentally, it's a distributed processing engine. We think of it as a stream processing engine. That's kind of what most people would say if you just cornered them and forced them to define Flink for you. If they knew what it was, they'd probably say stream processing. But it's got this interesting take on the world where it really sees batch and stream as two sides of the same coin. So it's capable of processing batch data and capable of processing streaming data through those Java APIs, a couple different Java APIs, and SQL as well.
Not only you can use this from different APIs, there's a bunch of ready-to-use connectors.
Yes. So there's stuff out there in the world that's got the data that you want to process, right, outside of Flink. It's probably a Kafka topic. But, hey, maybe it's a file, maybe it's in a database somewhere. There's lots of options. You get that stuff into Flink, you build your stream processing topology either with the Java API or in SQL, and then you write that data to one of those other things. Often, again, in from Kafka, do your stream processing, out to Kafka. It doesn't have to be that, but it's often that.
We're recording this video in 2025, and there is obligatory requirements of every speaker to mention AI somehow, and this is not exception here. Majority of the time, you're dealing with the data that comes from either files and Kafka, but these days, we see more and more workloads that needs to somehow interact with different existing models or models that you host yourself or some of the services. And the Flink is not exception here. So Flink provides support for interacting with the existing models like model providers like Anthropic or OpenAI. And the cool thing for the Flink, it also looks like it's another source, and you can or perform some sort of like a function like ML_predict on top of some of the functions or some of the API calls that are available in like OpenAI. And this opens up very cool possibilities by integrating real-time data from Kafka with your AI use cases.
What is Flink SQL? Well, Flink SQL is a standards compliant dialect of SQL that you can use to process batch or streaming data with Apache Flink at scale. And as Victor said, he's a Java guy. I'm a Java guy. I mean, if you're a Java developer. You can write some SQL. You're not as good at it as the true data people. I think we all know that. But Java would be a place where we would feel more at home. So we might go to, say, the table API if we were looking for the more modern Flink interface, or some of the older stuff is done with the Flink data stream API. But I'll tell you what, that stuff doesn't demo as well. Like, I mean, I think it's cool to watch Victor write Java code live, but you'd rather watch him write some SQL.
Or you can watch the course on table API at developer.confluent.io.
Yes.
And today, I think we need to answer a very important question, Tim. I don't know how many times you get this question, because I'm getting this question a lot of times when I'm speaking about Flink and I bring this up a little bit SQL, and all of a sudden people got excited saying, "Oh, it's a streaming database." So Flink is a database. You said that you like to corner people, ask them about stream processing with Flink. It's already solved. That's how we're doing this, one person at a time.
Mm-hmm.
Same way how the Flink deals with the streaming data, one event at a time. But what about SQL, Tim? Like, what's up with that? It's a database.
Yeah, it's not a database, actually. And there's a really important distinction that I think separates databases from non-databases. You can't ask Flink questions. You can use SQL to define, or really to declare, the computation that you want it to do on the events that it brings in. And then it spits out events as its results, and it's perfectly natural to express those in SQL. But what you can't do is ask Flink questions. And a database is fundamentally a thing where you put stuff and then you come back and you ask about it. And you can't really ask Flink anything. It doesn't have a query interface the way a database does. So it's a middle stream processing engine that's going to do the work to prepare data to be ingested. It's the basic picture we're painting here.
In this case, it fits very well with our current demo, because we do have a very good query engine that does a very good job on getting this data. So essentially, the thing that we're gonna showing you today is that Flink works with Apache Kafka. Flink performs some of the computation. And basically, for many use cases, Flink can be used as an engine to do materialization, materialized view, constantly updating materialized view for systems like Apache Pinot, right? So this is what we're going to be demonstrating for the next one.
So the idea here is that you've got data. It comes from somewhere. Maybe your application is generating it. You're pulling it in from a database. You've got some external source, whatever. Data isn't a Kafka topic. You want to get that into Pinot. But like I like to say, what would be the odds that it's already perfect in the form that you need it to build the table in Pinot that you want to build? You don't get that lucky very often. So you have to do some stream processing in the middle to kind of squish that around, maybe add a little bit, and then dump it into Pinot where you can query it in real time.
And this is, ladies and gentlemen, KFP stack, Kafka, Flink, and Pinot. And let me show you how it works in a real life if we're going to be continue doing same stack. So in Confluent Cloud, I have a ability to run a Flink queries on top of the data that available in my topics. So if I'm going this my workspace for my SQL, as you can see here, there is very interesting, particularly for me, I don't know for you, Tim, but it's very interesting. The SQL query, what takes some data that arrives from the system, and as Tim said, it turns it into something that would be at least ready to be presented in some sort of dashboard. So instead of having like a timestamps, we actually turn it into the something that people can make a decision today. Specifically, we're interested in the time of the day, right? So it's morning, midday, evening.
Or whether a flight is delayed. You don't want people comparing epic timestamps on the dashboard to see.
Exactly.
It's not practical. We want a word that tells us. Yeah. And this is super lightweight stuff here, folks. This is a really simple example. These pipelines can be arbitrarily complex. They can join to enrich from other data sources. You can let your imagination go wild with what you're going to do in the streaming pipeline here.
In this particular case, we might enrich this data that comes from from operational system, like each individual flights run and land inside the Kafka. But we might have some sort of operational data that we need to merge this from. So in this use case, we do have an airline name as a field, but in real life, usually we're going to be using codes. And in order to turn code into real airline name, we can use things like adjoining things inside here. Now, so this, as a result, we're also using schema and Pinot and data manager from Starter Cloud was able to infer this information from also schema registry, from data contract that is assigned inside the Kafka. So they work very well together. And now, so this enriched information will be available for query. I'll just showing you like whatever is available. And again, if I would say the count and show you that this is information is constantly updating, I'll just run this real quick. We have this number. And if I run this a few more times, as you can see, the number is growing. And the way how it works, because this is continuous query that runs inside of Flink and insert all the new records that were transformed using this SQL and using this SQL, basically. Yeah.
And again, we're keeping it simple on these queries, not trying to melt your brain with anything. But Pinot is capable of very sophisticated filtering, grouping, aggregating, even joining inside Pinot. If you want to join there, it's all possible. There's a lot more than words.
This is very good point, Tim, and this is very great segue to the point where people might thinking, okay, so what's the SQL there? What's the fuss? Like, why you want to do this on the Flink side of things? Like, why you bringing the Pinot here? Can you do everything in Flink and after that do this in Kafka? What's the advice we can give people who are focusing their data pipelines using SQL?
Yeah, well, the more you're going to ask the database to do, the harder it has to work, the longer it's going to take. So this all comes down to what your latency requirement is. Pinot is optimized, hyper optimized at every level of its engineering for low latency, but it'll still do a lot. You can still do arbitrary joins between large data sets. That's a slower operation. That's not going to take 10 milliseconds. That might take a second or more on production data sets. If that's too slow, well, you want to do that enrichment, if you can, in the streaming layer. So you've prepared data that's a little denormalized for Pinot, so you can do those like hyper low latency queries there. On the other hand, if you want that flexibility, you want richer data that you can kind of mix and match and do what you want with in Pinot, and your latency requirements are relaxed enough that it works, well, then absolutely you want to dump that relatively less processed data into the database. So you get to engineer based on the latency that you need and whether you want to do that compute in the stream or in the database.
I might be preaching to choir here, but I also want to bring AI in this particular case. So with stuff like the model inference that's available in Flink AI and in Confluent Cloud, you will be able to not only perform your traditional joins between some sort of like a table to stream or stuff like that, but also you can generate some new information. So in this case, we will bringing not only real-time analytics to users through powers of Pinot in integrating with the custom dashboard, but also we're bringing some sort of like intelligent and generative intelligence analytics, and we're joining together real-time analytics and AI. And the Flink is a cornerstone because Flink can get the data not only from Kafka. It has a great connection from Kafka, but everything is integrated. Using the Flink, you can bring the even like AI models into your conversation. But hey, more about Flink, Kafka, you can find at developer.confluent.io. I hope this session was informational, entertaining somehow. We tried. And I hope to continue this conversation somewhere online, hopefully on developer.confluent.io. Or, hey, you can find our social tags here and follow us in Twitter, also X or Blue Sky.
It would be great to talk. Thanks.
It was Tim Berland from Confluent and Victor Gamo from Confluent. And as always, have a nice day.